it was more focused on geospatial data, which is obviously very connected to a lot of the work that you're doing here as well. So I'm very interested to sort of hear how everything's been going. I think Anna will probably reflect this here as well, but I think more than anything, we just wanted to get a sense of what was working, if there's things that aren't working that we can help out with. And like Doug said, I think to get you all together in sort of the same place so you can all talk to each other. Just a call out, if something like this is helpful, we also have other forums, literally forums, where you can talk to each other. We had shared that information previously, so all of you should have access to a Google group where we can sort of communicate across the project. So if there are conversations that start here and you want to sort of take them somewhere else, we do have mechanisms for you all to communicate with each other sort of outside of just this webinar. But for me personally, I'm excited to sort of hear about the project, see the updates, see where there might be ability to help you all out, and especially with the other webinars that are coming up over the next couple of days. And then, yeah, if there's anything that's blocking you, happy to try to figure out how we can help there as well. Anna, did you want to say a few words?
Yes. Hi. Hello, everybody. I don't know if you can see my image. I'm actually out and getting home late from dropping my daughter. But yeah, very excited to be here today and have the opportunity to see the work that you guys have been developing in this program. So just for a quick background. So I lead the Amazon Sustainability Data Initiative, and I work very closely with Joe and his team, trying to understand how we can leverage Amazon's technology and the cloud in particular to really promote more innovation and problem solving in the space of sustainability. So from our perspective, we're really trying to understand how can we enable better access to data, better access to compute, and really help make a difference in finding solutions for these critical problems we are facing. So yep, I'm here. Let me know if you need anything. I'll be sitting at my desk in like a couple of minutes. And more focused, but look forward to seeing what you guys have to show and see. And as Joe mentioned, a very critical part of this is also understand where you might be experiencing roadblocks and where we might be able to help with that. So feel free to just voice if you have anything that is really preventing you from making progress. Thank you.
Great, thanks, thanks Joe and Anna for that. So just to let you know a little bit how this is going to work, we're in the introduction point here. I'll just say a few more words about GEO, and then we'll launch into the projects themselves. As you all know, you have submitted videos of approximately 8 minutes or so in length. We'll look at 5 of those today. And after each video, we'll have time for just a question or two, and then we will maybe move into a more technical session where if there are any roadblocks or any obstacles, as Joe and Anna have mentioned, we'd like to talk about that and anything else that might be of interest for you. So just a word about GEO. I think you probably are all familiar with GEO by now. I just wanted to let you know what the vision of GEO is from our strategic plan, which was approved at a ministerial summit back in 2015 in Mexico City. GEO is an intergovernmental partnership that envisages a future where decisions and actions for the benefit of humankind are informed by coordinated, comprehensive, and sustained Earth observations. So we're very interested in finding ways to not only open up access to Earth observations, whether that be in situ or remotely sensed or marine aircraft, whatever. These countries come together, and the participating organizations in GEO, such as the WMO, several UN agencies and research institutes, to look at how we can open up access and also apply Earth observations. The Cloud Credits program started about a year and a half ago, maybe a little bit more. The point of this program is to help especially developing countries make use of cloud services to understand what's available, also understand what Earth observation data is out there and how how technology is available to process and analyze that data. And then in particular, we were interested in projects that can be in support of some major policy, such as the Sendai Framework for Disaster Risk Reduction, the Paris Agreement, or the Sustainable Development Goals of the United Nations. So before we start, just a reminder to put yourselves on mute when you're not speaking. And then please, as the presentations are going along, if a question comes to mind, please put it in the chat window. That way we can keep track of your questions and refer to them when we get to the Q&A session. Now I'm sharing my desktop to show the videos, so I don't think that anyone's webcam is available, and so you may as well just switch them off for now. When we get to the Q&A, we can put them on, but for right now, I think it's probably just as well if everyone switches off their webcam, and then we can switch them back on when we come to the Q&A. So without any further ado, the first presentation is going to be brought by Avik Bhattacharya, who comes to us from the Indian Institute of Technology in Bombay, India. They're looking at processing chains for crop biophysical parameter estimation using SAR data in the Amazon platform. And I will now find his presentation, and we can have a look. So here we go.
Hi everyone, I am Narayan Rao from Micro Remote Sensing Lab, IIT Bombay, India. Through this presentation, I am going to share our experience with Amazon Web Services in solving our research problems. Since the last 2 years, we have been using AWS services such as Elastic Cloud Compute, Elastic Block Storage, etc. In particular, we are using AWS services for agricultural monitoring and mapping, utilizing multi-sensor Earth observation data. The details of the project grant are as follows. Our project lead is Dr. Avik Bhattacharya from IIT Bombay, India. We have been allocated with an annual financial grant of $20,000, and we have efficiently utilized the fund for our research work. We have taken up many objectives of agriculture monitoring utilizing multi-sensor Earth observation data. Proceeding further into the details of the work carried out, the first objective is leaf area index estimation workflow for Sentinel-1 using AWS and Snap. We have observed a limited exploration of SAR data on a cloud-based platform like AWS. This observation led us to investigate a set of processing pipelines in a cloud-based platform for delivery of inventories. Subsequently, we proposed the AWS for AgriSAR framework. The key processing blocks of the processing pipeline are configuring the Snap processing in AWS, Sentinel-1 pre-processing with graph processing tool of Snap, and LAI map generation. LAI estimation workflow for Sentinel-1 SAR data using AWS and Snap is as shown in the following flowchart. First, we import the in-situ measurements into Amazon's EC2 environment. Then we download the Sentinel-1 data. Now the second step is to pre-process the Sentinel-1 data and extracting the backscatter intensities according to in-situ data. This is accomplished by our proposed Sentinel-1 pre-processing chain. As a final step, we calibrate a semi-empirical vegetation backscattering model known as water cloud model and utilize it in PI estimation and mapping. The required processing algorithm is openly available at the following repository along with a set of configuration guidelines to utilize the processing workflow. Going into the details of the Sentinel-1 pre-processing workflow with graph processing tool of Snap software. The processing flow generates registered and geocoded polarimetric covariance matrix elements from time series of Sentinel-1 single loop complex data. As shown in the figure, the pre-processing pipeline is divided in 4 modules of graph, starting from importing the data to exporting the data. Starting from importing the data to the exporting. Starting from there. starting from importing the data to exporting the data into the exporting the data in colorimetric covariance matrix format. The required processing algorithm is openly available at the following repository along with a set of configuration guidelines to utilize the proposed workflow. Proceeding to the next objective, land area index map generation. Here, the processing workflow remains the same. However, to estimate PAI, we have utilized water cloud model as forward model and support vector machine regression model as PAI estimation model. Here, you can see the generated PAI maps over the test site Vijayawada in India. Rice is the dominant crop of the test site. Here, from the figure, we can observe the spatial and temporal dynamics of PAI over the test site. We can observe a clear increasing trend in the PAI values from early tillering stage to the fruit development and dough formation stage of the rice. The table shows the statistical metrics of the PAI estimations. From the table, you can observe that the Pearson correlation coefficient for PAI estimates is greater than 0.75 in all the phenology stages, along with a lower RMSE value. In this figure, you can observe the crop inventory maps produced utilizing the similar workflows over another test site in Manitoba province, Canada. The required processing algorithm is openly available at the following repository, along with a set of configuration guidelines to utilize the proposed workflow. Similarly, we have also introduced 3 vegetation descriptors for 3 different colorimetric star data. Further, we have utilized these indices in crop biophysical parameter estimation. We have also developed standalone tools to extract these vegetation indices from colorimetric star data. The processing tools can be downloaded from the following repositories. We have also utilized our proposed vegetation indices to estimate crop biophysical parameters from simulated NSR data. We have obtained promising results from simulated NSR data as well. The figure shows correlation plots of estimated crop biophysical parameters utilizing proposed vegetation indices and simulated NSR data. Recently, we have released a QGIS plugin which can generate various vegetation indices and decomposition parameters from colorimetric star data. The plugin was built using Python and the source code is openly available. Here is the list of functionalities currently available in Polestar Tools plugin. However, given the pace of research work by our group in SAR colorimetry, there will be more functions available in near future. The plugin source code is available at the following repository. Here comes our future plan with AWS. Since the GPU support is currently unavailable for our region, we are pushing ourselves to develop efficient workflows to handle large volumes of Earth observation data. We have planned to utilize S3 bucket and AWS Lambda function to achieve our research goals. And as always, we release the source code to the public. Here is our research work submitted to the peer-reviewed international journals utilizing AWS. And here is our already published research work. Thank you.
Okay, thank you very much. I would like to, first of all, can everyone hear okay? Can everyone see the presentation? Is the volume fine?
Yeah, it worked okay for me.
Okay. Good. Okay, good. Do we have anyone have a question for for this presentation?
I have one if there's if nobody else has one. Thank you. This is super interesting. So you mentioned at the end that GPUs weren't available in the Mumbai region. Is there a reason why you need to use the Mumbai region, or could you use a different region that might have access to those GPU instances?
Actually, we are not sure that are we able to access the other regions as well, because currently our project has been assigned for the Mumbai region itself. So we are not clear or sure that we can use the other servers as well.
Oh, yeah. So in general, I mean, feel free to reach out to me. This is Joe. Feel free to reach out to me if you see anything weird here. But in general, you have an account. An account has access to sort of all the AWS regions. So you shouldn't be locked into any specific regions. There are caveats to this. There are some regions that aren't available to everyone, but for normal accounts, you should have access to other regions.
Oh, okay. Thanks a lot. Yeah, we
Yep.
will try, and if we face any problems, so we will come back to you then.
Cool.
Okay, thank you.
Okay, thank you. Any other questions? Okay, if not, let's move on to the next project then. We'll be hearing from, let me rearrange a few things here. So we'll be hearing from Dr. Boniface Agricu, and the Kenya Agricultural Livestock Research Organization, KALRO, is his institute. And he is looking at the lack of accurate, timely, and reliable satellite Earth observation and associated data to support effective decision-making. And without further ado, we'll go to his presentation.
Hello, my name is Kizito Odhiambo, and I will be presenting today on our project, the Geographical Information System for Sustainable Agriculture in Kenya and beyond. This is a project that is being led by Boniface Agricu from the Kenya Agricultural and Livestock Research Organization. With our project, we are trying to address the challenge of, on the one hand, we are seeing there is a lot of agricultural research data available in Kenya, but we lack accurate and timely satellite Earth observation data, and looking at how we can be able to integrate this satellite data with already existing research information, specifically to generate decision-making or to support decision-making for stakeholders within the agriculture ecosystem. Of course, looking at this from the perspective of also weather and climate variance, which is increasing the risk of the agricultural sector per se. So we are looking at how do we enable the agricultural sector to make better decisions, leveraging on the already existing local content from research on the ground, and also putting in the information that is coming in through Earth observation data, where we lack capacity of including this into already existing working processes. And our solution for this within this project has been to look at how we can be able to build a system that enables us to use this space-based data and agricultural data from the ground to be able to support decision-making for not only farmers, but also other actors in the sector, from policy makers to industry. Looking, for example, at the challenges of smallholder farmers, we are looking at, on the one hand, questions about where to grow, what to grow, based on their location and the agroecological information. And this is information that has already been developed for different areas. We have suitability maps, but trying to understand how the current situation is progressing, the current season is progressing, has been a challenge, because you need to now leave the research data and look at if you're able to obtain observed information. So we are hoping through this project to basically provide a decision support system for different stakeholders, where they're able to answer some of the questions relating to observed information on our monitoring activities. Where did it rain? How much? Or which sections of the country need interventions, for example. So during this project, we started by looking at how we can be able to set up the Send2Agri system. And the Send2Agri software basically was to provide us an opportunity to monitor crop development during the season with services such as dynamic cropland masking just after planting, at the middle of the season, and then at the end of the season, to understand what varieties of crops have been grown within the country, to also be able to determine the crop type map and identify the vegetation status of the crops. We had initial challenges setting up the Sen2Agri system, so we resorted to trying out the Open Data Cube technology, which is an open source technology used to basically store and also retrieve satellite data for area of interest. So we have configured and deployed an Open Data Cube for Kenya to be able to analyze satellite data, especially from Sentinel-1 and Sentinel-2. And going with that is a Jupyter Hub environment, which is basically a coding environment, which we are using to develop algorithms, especially looking at crop phenology. Now, to be able to capture as well data from the ground, we have been doing a geotagging activities with smallholder farmers using feature phones, which means we are not relying on internet, we're not relying on farmers having smartphones. And this is because most of the farmers still have feature phones. Some have smartphones, but access to internet is still limited. And with this technology, we have a GPS device which has a SIM card inside and a 3-meter accurate sensor. And a farmer can basically send an SMS to a designated number, and we are able to retrieve, or we're able to ping that GPS device and retrieve the position of the farmer and the field. And now based on that, we are able to demarcate the field boundaries and then run an object-based kind of analysis of vegetation and the indices that we want to generate through that, and also are able to send information to farmers, especially weather information, through our existing system within Calro. We have also initiated activities to collect information from farmers, so enabling farmer surveys that support us to get self-reported data from farmers. This is important to us because it helps us to identify planting dates, crop types, and such kind of information. And it has also proved very beneficial to us in collecting information about the impact of desert locusts, especially during the long rain period, March, April, and May of last year. We are now looking at how to use this data that we are collecting from farmers and the data that we're able to analyze from satellite data with the already existing agricultural research information to be able to develop models that support us to look at the water requirement satisfaction and also looking at crop models to help us do yield prediction. Some of the challenges that we've been facing, I had mentioned before, the limitation of not being able to set up the Sen2Agri server, because we find that is a very good starting point to be able to look at how to maybe also improve the already existing algorithms within the Sen2Agri system. And we want to look at how we can be able to still go ahead to deploy the Sen2Agri system on our server for testing. On the other hand, we wanted to reach out to more users of such systems, decision makers from across the industry, from policy makers to private sector companies, to find out about how they want to interact with such kind of a tool. So due to COVID-19 limitations, this affected our movement in the course of last year mainly. And because we are capturing field information, we have had challenges in doing automatic field delineation. So we would want to look at how to obtain expertise that can support automatic field delineation, which is quite a challenge for smallholder farmers. And this can help us basically to analyze better what is growing the crops and also look at yield potentials. Looking at going forward, we want to geotag another 1,000 farmers to help us have good data that can be used within our models to understand the kind of decisions that need to be made that need us to basically do the interoperability of field data or research data and data from Earth observation, and also looking at how we can set up a web application for this. We're looking at this as an opportunity to basically improve the ground truthing opportunities for what we have available, and also supporting policymakers to make decisions based on not only research data that is available, but also on Earth observation data. Thank you very much.
Okay, thank you very much for that very interesting presentation. Would there be any questions? Okay, so there's a comment here in relation to the issue on setting up a server for Send to Agri, the GEO Secretariat can support that, can provide help. I mean, Gilberto, maybe you want to clarify that?
Yes, good day. Hello.
Hello.
Well, hello. Good day, everyone. So just for friends in Kenya, there is a version of Send to Agri which can be made available in Amazon. We actually, I think, yes, we have a version. The Secretariat has a version of Send to Agri which can run on Amazon. And what we have to do, and now we work on this with Doug, is provide you with what the Amazon machine image, so you could start Send to Agri there. Because I think, of course, yes, it is not designed. It has not been designed to be used in connection with Amazon originally. So you're right. It's not obvious how to set it up. But we have now, and I'm looking at the Amazon page of the Amazon account of the Secretariat, and we have a version of Send to Agri there. So what I'm going to ask, well, work with Doug and the team, so you can have that version available as an Amazon machine image, and then can you start? And then you can consult us. We have a lot of material on how to set up a Send to Agri and how to do it. A lot of things accumulated. So I think I suggest you contact us from the Secretariat that we can provide support to you on that, on getting Send to Agri right. Thank you so much.
Great.
Thanks so much, Gilberto. This is Kizito from the Calro team. I appreciate the support that you are willing to offer us, and I will be reaching out to you to find.
Okay.
Thanks a lot.
Thank you.
Kizito, just note here also in the chat that Michael Humber, who will be speaking a little bit later on, says that they're working with a version of Send to Agri that they would be happy to help as well. So looks as though you've got a few resources that maybe would help you get past this roadblock.
Yeah, thanks a lot. Great. Thanks, Michael. I will also be reaching out. I appreciate the support that you are offering us.
Okay, any other questions? If not, let's go ahead and hear from the next project. Let's see, so. So the next project is coming to us from South Africa. Seems to be taking just a moment to load. So this is a this is a project that is led by the South African National Space Agency. Nosiseko Mashiyi is working on or taking the lead on the project, which is called Africulture's Decision Support System. I'm not sure. Okay, there we go. There, I don't know what the hiccup was there, but anyway, here is Nosiseko and her project. So let's go to the video.
Good afternoon, everyone. My name is Nosiseko Mashiyi, and I'm from the South African National Space Agency. I'm the lead for the Agriculture's Decision Support System Community Vision Project. I work with Mahlatsi Fanyaho and Ebo Paramahoba, also from the South African National Space Agency. Africa is one of the continents that is challenged by food insecurity. This is a result of weak governance and agricultural system response to the pressures of climate change, competing land use activities, and population increase.
Doug, sorry, can you turn the volume up slightly? The volume's just a bit low.
Which leads to food insecurity in the continent. food security challenge can be tackled by the
Thank you.
smart solutions, such as the cloud-based agriculture.
Doug, can you restart? We've not been able to hear from the beginning.
Okay.
Get the volume as high as you can.
Good afternoon, everyone. My name is Nosiseko Mashi, and I'm from the South African National Space Agency. I'm the lead for the Agriculture's Decision Support System Community Vision Project. I work with Mahlatsi Fanyaho and Ebo Paramahoba, also from the South African National Space Agency. Africa is one of the continents that is challenged by food insecurity. This is a result of weak governance and agricultural systems response to the pressures of climate change, competing land use activities, and population increase. These factors have a negative impact on agricultural production, which leads to food insecurity in the continent. The food security challenge can be tackled by the introduction of smart solutions, such as the cloud-based agricultural decision support system community vision, with products derived from crop models, weather data, and air preservation data for near real-time agricultural monitoring and early warning. The ADSSS CV, which is the Agricultural Decision Support System for Community Vision, provides 4 of the 6 agricultural services, namely climate service, which provides information about mid-term climate variability and long-term climate change scenarios. The second one is the crop service, which provides information on crop condition, crop yield forecast, and crop types. The third one is water service, which provides products for water quality and quantity assessment and monitoring. The products include water body mapping and soil moisture assessment. The fourth one is livestock service, which provides information for decision-making in livestock production. And the products include grazing and range land condition mapping and grazing and range land mapping. The second solution would be the use of the Central Agri system for the development of these products to support the ADSS. The system provides access to image data and products such as the NDVI, LAI, and FAPAR. Coming to the project status update, the Agriculture's Decision Support System has been set up in the AWS environment with the specifications that are listed on the slide, such as the 32 gig RAM and also the SSD, which is 500 gigabytes. The service server is also being set up with the specifications that are also listed on the slide. And the servers that have been uploaded so far are crop and water service. However, the product development for these services or other services as well is ongoing. If you look at the right-hand side, the Central Agri system as well is also being installed and it is currently running, and various products have been produced from level 2 to level 4. As you can see that there is an example of a level 3 product, which is LAI, for crop growth monitoring every 5 days. It is scanned throughout the growing season in Harrismith, South Africa. There's a couple of those that have been produced. If you look at the top, where just below the Central Agri name, there is a table there which shows the highlighted instance of the Central Agri, which is running on the AWS system. And also, if you look at the bottom on the left, there is on the table, similar table, the instances for the agriculture's platform and the services server are also highlighted in red. And then looking at the timelines, starting with the tasks, the project management task and coordination, that one is ongoing. It's focusing on general project management. The second task, which is the migration testing and the deployment, this focuses on the setting up of the ADSS CV on the AWS platform, and that has been done. However, not all services are available. And then moving to the task number 3, which is the system and products maintenance, which focuses on the installation of the Central Agri system and that has been done as well. However, the product development is still ongoing, hence the status is in progress. Moving to the task number 4, which is the quality assurance, that is also in progress. The validation exercises are ongoing. However, there are delays in that due to limited validation exercise because of the COVID-19. Moving to task number 5, which is capacity building and user appraisal. That one has not been started yet, and it focuses on training and also getting feedback from the users or stakeholders for the improvement and customization of the system. And then if you moving to the challenges and roadblocks, there are limited validation exercises in the agriculture project due to COVID-19 restrictions in various countries in the continent. Also, the project has been granted an extension of 12 months, which may also delay the completion of other activities that are related to this project. We've also encountered some delays when we're doing the product development using Central Agri. That is probably due to the volume of the data and the size of the area that we are working on, which slows down the entire product development process. The next steps and expected impact. We will continue with the validation exercises for the agricultural products and also do quality assurance of the system and do capacity building and user appraisal exercises. In terms of the expected impact, we're expecting to see the improved agricultural production in the African continent and also more uptake in use of cloud services in the continent. Thank you.
Okay, thank you, Nosiseko. Thanks for a very interesting presentation. Do we have any questions? Let's see. Hopefully that you could all hear after I tried to raise the volume to the maximum on my end. But anyway, I had a question in regards to, I think it was the penultimate slide. Nosiseko, you mentioned delays in product development, and I wonder if this is an issue for not just your project, but for several projects. You know, the program started, you were granted the credits and kind of left to sort it out somewhat on your own. Do you feel that you would have benefited from, you know, perhaps some technical assistance at the outset, or do you think that, you know, was it your observation that you had the necessary expertise there at Sansa to make use of the credits right away? Can you give us a little more, you know, fine print there in terms of product development? What were the delays?
The delays that we had, one is that we took time to actually install the Central Agri, which we got help from Gilberto and the team. And secondly, the delays that I'm talking about is the process that sort of slows down, it sort of delays the actual processing. It takes longer, not necessarily that the delays in terms of us starting the thing. As a result, we've sort of decided to use the Central Agri for processing only for the pilot sites. And also one of the reasons that we're doing that is also we are watching the credits as well, because we're still going to use them for running off the actual agriculture system. So because we are required to produce, to develop projects for the continent as a whole, so we realize that to process that volume of data is going to be a lot, it's going to use a lot of credits as well. So that is the delay that I'm talking about, is the actual process, because it sort of slows down, not necessarily the task.
Okay, good. Thanks. Any other questions for Nosiseko? I saw that Sophie Monton joined us. Welcome, Sophie. Sophie has been well. You're behind the development of the Send2Agri software package.
Yeah. So hello, hi everybody. Yeah. So for me this is really a pleasure to hear this kind of presentation from an external user. Using the system without any interactions with us. So I'm really interested in having this kind of feedback so that we can continue improving. So thank you very much for your presentation and for your work.
Okay, if there are no other questions or comments, let's move on. So the next presentation is coming to us from the University of Maryland, the NASA Harvest Consortium. And this is a project led by Michael Humber, who is looking at developing observations and ground data collected via crop tours and high resolution photo reinterpretation to compare the popular off-the-shelf Send2Agri system with solutions developed in-house. So this will be interesting. We've had 2 presentations that featured Send2Agri, and we'll have one now that takes a different perspective. So without further ado,
hello, everyone, and thank you for the opportunity to present in this webinar. I'm Michael Humber. I'm an assistant research professor at the University of Maryland and the data lead of the NASA Harvest Consortium. I'm presenting on behalf of many collaborators, but I'd especially like to thank Dr. Hannah Kerner, Blake Munschel, and Dr. Inbal Beckversha for their contributions to this presentation. Our project is titled Mapping National Scale Agricultural Practices, wherein we aim to monitor cropland and crop types in several countries around the world. In this work, we're looking at the Send2Agri system for generating agricultural products, including vegetation indices, crop area maps, crop type maps, and crop phenology indicators. It's a turnkey system used in several countries around the world, and the implementation that we're using is based on a version that was provided to us by GEO-AWS. Our goal here is to understand how the system performs both generally, but also with respect to how it operates in the Amazon Web Services cloud. One of the main types of questions we're trying to tackle here is when we're dealing with the diversity of landscapes that we see in the right-hand picture with different crop types and different agricultural practices, how well does a one-size-fits-all system handle these differences in landscapes, and what are the costs, benefits, and pitfalls of doing so? In terms of our proposed solution, our first and foremost challenge here is collecting field data, because the field data is needed to train and validate the image classifications. We are working in several countries with local collaborators in Argentina, like the Buenos Aires Range Exchange, Swiss Re in Kenya, Lutheran World Relief, Plant Village, and National Agricultural Ministries. We plan to use this field data to both train and validate the outputs of Send2Agri and compare those results to in-house products that we've created under the NASA Harvest program. In doing so, we plan to document, summarize costs, and present any usage issues and a summary of the efficacy of the results throughout this project. In the end, we'll release the maps and the field data under the Creative Commons license that will be available for everyone to use in the Harvest portal. I mentioned the first challenge that we have to face here is field data collection, and as many of you can all probably assume, UMD and its partners have been unable to collect any field data in recent months due to the pandemic. Instead, we focused our efforts on digitizing data that we've collected in past campaigns, and this involves converting a lot of point types of data collected from windshield surveys into polygons. So this is a high effort activity that involves digitizing and actually drawing the boundaries of the fields that are on either side of the road when the collector identified the left or the right hand side as being a certain crop. To date, we've actually identified over 19,000 fields. Most of those fields were from 2018, but we do have a pretty well distributed sample between 2016 and 2020 and several countries around the world. But I should note here that this 19,000 field boundaries number can be a little bit misleading because a lot of these field boundaries are really just the boundary of the field. They don't contain the crop type. So we feel that while this is very useful data for doing a sort of image segmentation, its utility for classifications really depends on what it is you're trying to do. So because of that, we are also currently exploring other ways of getting field data, and this includes looking at solutions like using the Radiant Earth ML Hub data or data that's going to be collected under the Lacuna Fund in the next few months. In doing so, we're preparing ourselves for a big field data campaign that's going to take place once field travel is possible once again. So that means that we're developing forms for use with field data collection apps like the Survey 123 and ODK apps that are available from Esri and ODK respectively. And this is also data that will be released publicly under NASA Harvest as well. I should also note here that we're currently working on a program with the Buenos Aires Grains Exchange in Argentina that will aim to engage students to collect field data as part of their studies in an educational series on agricultural monitoring that will expose them to new types of technology for agricultural monitoring. For our comparison purposes, we do have a lot of work going on with how do we maximize the utility of those limited field data sets that we have, given that we're not able to go out to the field and collect data, at least for the near future. The way that we've been working on this, and this is work that's being done by Dr. Hannah Kerner, who's an expert in machine learning for agriculture, is to take this approach where she's using deep learning using long short-term memory neural networks, and being able to use transfer learning to take data from areas that are not necessarily near or adjacent to our study area and use those to improve the classifications in the study area itself. And in doing so, they're able to generate cropland maps both within and at the end of the season. So again, this is the benchmark and the data set we're going to use to compare this into Agri results against. And because this code is available on GitHub and free for anyone to use, we think that it's a reasonable comparison, even though the system itself is not quite as turnkey as the Send to Agri system. Using these methods, Dr. Kerner and her team have put together image classifications using these sparse training data sets for several countries, including Kenya, and that's the map that we see here on the right, with especially, not only nationally, but especially with a focus in Busia County. They've also created maps for Sudan, Rwanda, Ethiopia, several provinces in China and Brazil. So here we see an example of the map that was created in one of the provinces in China. I'm also leaving out here previous work that we've done with the Buenos Aires Grains Exchange in creating winter crop classifications that we can use as a comparison benchmark as well. In terms of challenges and benchmarks, again, the biggest challenge that we have so far is that it hasn't really been possible for us to do field data collection. This is due not only to local travel restrictions like we see in Argentina, where field collectors are unable to move between provinces, but also restrictions from our university as well, and just general health concerns that prevent us from going out to the field. We found that the data cleaning process is more time consuming than we even anticipated. On the right-hand side here, you see the results of a windshield survey, so those dots in orange. And the first letter following the number corresponds to the crop type that was on the left, and the second, the crop type that was on the right. We're finding that we have to augment these field data sets with a very high resolution imagery like Planet in order to find the boundaries of the fields and attribute those left and right labels to an actual two-dimensional space on the ground. In terms of working with Amazon Web Services, we know that the learning curve can be quite steep for new team members. In order for us to efficiently use the resources, this means that we have to either spend a lot of time training new members or provide significant oversight in order to prevent any sort of billing issues, overages from leaving instances on. And we've also found that the lift and shift model doesn't really translate well for computationally intensive tasks. So one of the things that we would normally do is like to iterate over these runs and maybe work our way from 70 to 80, 90, up to 100% of our goal in terms of study area. But what we're finding is that because each one of these runs in such a long running task costs a non-negligible amount of money, we really have to kind of hold our data until we are sure that we're able to run the entire thing. Otherwise, we incur costs along the way, and we really just have to run the big classification when we feel like we're ready for it. That said, it is not really possible for us to run classifications like we saw with those long short-term memory neural networks because we don't have the resources on premises to deploy in order to run those classifications. So while we do have that cost associated with running these models, this is really the only way that we can actually run these at scale, and that's been a major benefit of Amazon Web Services for us. So our next steps, again, we're sort of held back a little bit here by the pandemic, but we really need to expand our field observations, and this is to make sure that we're properly training the Sensu-Agri system in order to do a fair comparison. We also are planning then to run and benchmark the system against our existing classifications. The impact that we expect to see here is that this work will first and foremost help potential users of the system understand the costs and benefits of Sensu-Agri as a system being run in the cloud. And as secondary benefits, we do plan to release all of our data to the public. So there will be tens of thousands, in this case, field polygon boundaries and crop type locations for everyone to use, as well as the maps that will be released publicly, as well as made available, of course, to our collaborators and stakeholders. So with that, I thank you all, and I'll be happy to take any questions you have about this project.
Okay, great. Thank you, Michael. Very, very interesting. Do we have any questions for Michael?
I have a question, Douglas. This is Kizito. Thanks a lot, Michael, for your very interesting presentation. I see a lot of overlap with what we're trying to do with the team from Calro in Kenya. I'm just wondering, when you're talking about the polygons, what has your approach been so far with generating the field boundaries? Have you looked at any semi-automatic or automatic way of generating these field boundaries, especially for the smallholder farms that you've been working with in Africa? And then the other question that I have is with regards to the crop type discrimination. How has your success been so far with that for smallholder farms?
Great. Yeah, thank you for the question. Those are both really great points. The way that we've approached the field delineation is that, well, so I should say that in the past, with work we've done in Tanzania and Kenya, was that we would use our GPS apps to have someone walk the field boundaries and collect the boundaries that way. And we actually found that when we do that with the high resolution data, the GPS accuracy is a big problem for us, because plus or minus 5 meters is plus or minus 1 pixel. When you start working with things like Planet Earth's, a pretty significant part of the pixel size when you start to work with Sentinel-2. So we've actually been supplementing that with photo interpretation of the high resolution images. So we take the time when the field observation was taken for the crop type, and then we combine that with the most recent high resolution data that we can find and use that to determine the field boundaries. The problem with that, and the reason why it's still important for us to do the field work, is that we especially had this problem in Tanzania, but it occurs in a lot of places where the field boundaries are not visible from space necessarily. You can have adjacent fields where the fields are owned by 2 different farmers, but they're growing the same thing, and they look like one big field, for example. So when you have things where the field is marked by, for example, a pole or a stone on the ground that says this is where one field ends and one begins, that's stuff that we really can't capture with even the high resolution imagery. So it's very important for us to do both. In terms of the crop discrimination, it's sort of the same story. Again, I'll use the example from our work in Kenya and Tanzania, where the multiple or intercropping multiple crops per field is sort of a big problem we still haven't really been able to address with any of these systems, where we've seen cases where there's corn, beans, and sunflowers all grown in the same field. And that's very hard to discriminate with the satellite data. But for the individual crop types, generally the results have been pretty good. We're looking in 85% accuracy for the place that we've tested with both Sensu-Agri and with our own systems. So I think we're seeing good consistency there, but it really depends on the way that the crops are being grown.
Thanks a lot.
Great, thank you. Gilberto, you have a question.
Yes, yes, good afternoon. I have a question for Michael. It is related to the mention that you said that it takes credits to start running models. And I think that's probably has to do, this points a little bit to many of you who are using Sensu-Agri, and also to us and to Jim Fletcher, the issue whether the version of Sensu-Agri that you're using is a multi-process one or a sequential one. Because I don't know if you have done anything to make sure that Sensu-Agri runs on multi-sessions or multi-processes. And it's effectively, I'm worried about this because in this case, your virtual machine may have 48 cores, but you're only using one. So how are you making, are you checking that the version is parallelized or not?
We are, but we haven't been using the most optimal settings here, just because, you know, getting back to the original point, every time we do a run, every time we prototype something, we of course pay for the cost of prototyping. And you know, I think it's one of those things where watching the recording of yourself, you always notice the things that you sort of miss when you're giving your talk. But the point there is that, you know, we've done prototyping with the Centaur system. We've tried for small areas, and we think the results look pretty good, but we haven't really run it at scale just because we were waiting until we're confident in the training data in order to do that. So we are running and checking to make sure that it is using the multi-processing capabilities, but we are running it on relatively small instances. So we're running on 4-core CPUs instead of 6-core CPUs until we're confident that we have the data that we need to train the model properly. And once we reach that point, we'll scale it up. And in terms of time and efficiencies, we found that as long as the CPUs are running at 100% the whole time, in terms of cost, it ends up about the same, the way that the pricing is structured for the instances. So twice as many cores for half as much time ends up costing about the same. It's just a matter of are you able to utilize the full power of the EC2 instance.
Great. Okay. Any other comments, questions? Well, thanks again, Michael. We'll move on now to our final project today. So we're going to hear from Pham Bac Viet from the Space Technology Application Center in Vietnam. And his project is looking at using remote sensing for monitoring rice, paddy, and flood detection in the lower Mekong Basin. So
hello everyone attending in this webinar. I am Pham Bac Viet of the Ho Chi Minh City Space Technology Application Center. It belongs to the Vietnam National Space Center. On the behalf of the project team, I would like to present about our project, monitoring rice, paddy, and flood in the lower Mekong Basin. The Mekong River Delta is the main region for producing rice in Vietnam. It's a part of the lower Mekong Basin. It's the main area contributed to the national food security and rice export of the country. Each year, rice production of the Mekong River Delta in Vietnam contribute more than 90% of the market of rice export for Vietnam. The land area for rice paddy is about 2 million hectares. Rice is planted almost year-round with 2 to 3 crops per year, while in Cambodia, 1 to 2 crops per year. For national food security, rice paddy and flood monitoring are highly paid attention. The project aims to identify, map, and monitor rice paddy and its area and cropping system. The region of interest for this project covers the lower Mekong Basin, including parts of Mekong Delta in Cambodia and Vietnam. In Vietnam, we plan to include the entire Mekong Delta. With the approach of remote sensing, satellite data are used to update information, rice and flood. By using separate or single data or multi-day data, it is not timely updated. To solve this, to be on-time update information, it becomes more difficult for large area. If using sensor data, this requires a very large volume data, big data. Large volume of remote sensing data can be obtained from the Earth observation program. Obstacles of analysis and processing big data can be overcome by using a system of cloud computation. It is supported by Amazon Web Service. At this moment, we got it. Cloud computation system can do the task with lower cost and time consuming. It is more efficient compared to a single system like desktops or workstation. Another thing is open source program or for operation system and computation can be held to reduce the total cost. Some more requires programming with pattern scripting, identifying proper allocation for analyzing, processing data, and displays outcomes. The data of Sentinel-1 and MODIS for monitoring crash and flood is intended to use. So far, we have done some as leveraging the registry of open data on Amazon Web Service, automation of downloading and processing SAR data, Sentinel-1 and MODIS imageries. Sentinel-1 from April 2014 to August 2020 of the Mekong Delta were downloaded in Vietnam Park. These were downloaded from Amazon Web Service imageries. SAR Sentinel-1 includes 981 titles. Many of them just cover a small part of the Mekong Lower Basin. MODIS data from 2000 to 2020, more than 1,400 products. So far, we have only reached one of the two main objectives. Some are come as flood mapping using Sentinel-1 and MODIS imagery in the lower Mekong Basin. At the moment, data is stored on the instance in Singapore. Before this, we use instance in American region. We move is because in Singapore is lower than scope than in the American. We got some problem is difficulties in processing large amount of data quickly and reliable. It means big data processing. This is a new technology to us who are working on the field of remote sensing. The community about remote sensing using and knowledge on Python in Vietnam is not like enough. So the learning process and asking for advice is also difficult in terms of scripting. Experts on remote sensing but not know well about scripting Python or very limited or even not good knowledge of cloud computation, such as Amazon Web Service. Don't know what and how it can do, for instance, big data processing. Those ones who have knowledge and good on Python are not well in remote sensing or GEO-AWS. So far, so we must have to try to connect the two groups well on remote sensing and well on Python scripting. For the next step and expected impact, we try to complete flood and rash mapping using Sentinel-1 and MODIS. Expand the region of interest to the whole lower Mekong Basin, including Cambodia and Vietnam. Research validation and improve the quality or accuracy of algorithms. Publish a service for monitoring and detection via web service. Making and complete support tools for downloading and processing data, such as automation tools. Providing interface for users to making mapping, time series visualization and analysis. Various users can access like local administrator, farmer, or Ministry of Agriculture. Thinking and knowledge of how big data is processed by using cloud computation in field of remote sensing and GEO-AWS, unlimited by infrastructure, separate computers. It's on of my presentation. Many thanks to the Earth Observation Cloud Credits Program. Thank you, Dr. Creed, for organizing this webinar. Thank you all for your listening this presentation. Thank you.
Okay, thank you, Phan Ban Viet, for that interesting presentation on rice paddy monitoring and flooding in the lower Mekong. Do we have any questions for FAM? Gilberto, you have a question.
Yes, it regards the point that FAM stated about, I would like him to elaborate a little bit more on the difficulties he had. He mentioned cloud computing and the other and Python. So could you elaborate a little bit more about what is the most difficult things for you?
So far, we are a little bit limited on resources for scripting using Python. So someone know well on Python scripting is, but do not well good on remote sensing. So it's difficult when scripting and looking for algorithm or scripting related to remote sensing data processing is a little bit difficult. But another one who know on remote sensing is not so well on scripting. So now we try to connect the two groups together with had a better result.
Okay, I think your point is well taken. Specifically, there is not yet a good set of scripts that you can borrow and learn from to the use of Python and cloud computing for remote sensing. I think these things are just coming together.
Yeah.
But I think this is an important lesson for us here at the Secretariat, insofar as we have to consider this point for the, let's say, the continuation of the Google AWS program. And how do we ensure, because I'm sure some of those who have presented their work here have gone to the similar learning processes, and how can they share that information with you to a forum or to a place where we could exchange views on certain things. I mean, it's known that there is the Python community, which are the hackers, you know, the computer guys. There's the remote sensing people who understand imagery, and the two communities are not necessarily, I mean, they're separate, and you need to bring them together. So I think we have taken note of that. I don't know if any of those who have also presented today or attending would like to share more a general view on this, because I think this is a quite useful comment that you have made.
Yeah, thank you.
Anybody else like to weigh in on this point? Maybe Joe or Anna, do you have any reactions or any thoughts on this or some of the other obstacles that have been mentioned?
Yeah, for sure. I can start, and then Anna, we can see if you had anything you wanted to add. So I was taking some notes during the presentation. So first of all, thank you everyone for the work, first of all, but then also for coming on here and sharing the work with everyone. So just a few things. I was trying to figure out what I could say that might be useful for a number of the groups. And so one thing that I thought might be interesting, if you don't know about it, is often what we see in a geospatial context is there's sort of two ends of the spectrum. You're either doing sort of real-time analysis, so a new satellite image or a piece of data comes in and you act on that, right? And those are generally things that happen quick. They're smaller pieces of data you're working on, like one satellite image at a time. But then the other end of the spectrum, which a lot of you are doing here, is sort of bulk reprocessing, right? You're processing a whole bunch of data at once. When you're sort of doing those sort of large scale processing jobs, they don't always have a timeliness requirement, which means you don't necessarily need to get it done right now, right? You can take a little bit longer to do that. And so if that's the case, something you might want to look at is called the spot market, right? And so this is just a feature of AWS, specifically for EC2. So this makes the most sense for those of you who are sort of using EC2 instances. And what you can do is you can say, if an EC2 instance normally costs 30 cents an hour, right, for the EC2 instance you're trying to use, you can say, I only want to use that EC2 instance if it is 20 cents an hour, right? And then what AWS does is if we have unused capacity, it will auction off that unused capacity at lower rates, right? Because it is better to get somebody to pay for something, some usage, rather than have people just not use it at all. And so you can get much lower prices on the resources that you're trying to use. The flip side here, though, is that you are waiting for that resource to get down to the price that you set. And so if you look at the price reduction, I think our marketing materials say something on the order of 90% savings. In practice, I've more seen things like 70 to 80%. And so I think it just depends on how aggressive you are waiting for the price to come down. But if you're sort of doing these large reprocessing jobs and you don't need it to be done right now, looking at using the spot market might be something that you want to do. And if you're using other services like AWS Batch, which basically helps you run these large batch workloads, it doesn't cost anything itself. You still just pay for the underlying compute resources, but things like Batch help you work with the spot market more easily. And so it'll basically run your jobs when it reaches the price threshold you set. And then it'll keep the other ones waiting until the resources come down to that price. So just wanted to call that out as something that might be of interest for you all. The other piece that I'll say, and then I'll see if Anna, you have anything, or if anyone has any comments on some of what I've said here. The other thing that might be of interest for you all is, it was mentioned once in one of the presentations, but we have the registry of open data on AWS. This is registry.opendata.aws. Hopefully, if you search for registry of open data on AWS, you should find it as well. But this lists a number of different data sets, right? So a lot of the data sets that we saw listed here were Sentinel-2, Sentinel-1, but there are a whole bunch of other types of data sets. I think Modus was also mentioned, but there are a number of other data sets, right? Specifically, if you were looking for, I saw agro weather mentioned, right? So if you're looking for forecasts, there are a number of meteorological agencies around the world that we work with to make global forecast data available. And so similar to the way that, say, the Sentinel-2 or Sentinel-1 data is made available in an S3 bucket, a lot of these forecasts are also made available. So if you're looking for other data sets to use to bring into your pipelines, be sure to check out the registry of open data, because it's a similar concept where we're trying to work with the data providers to make this data as easily and frictionlessly as available as possible in the cloud for you to use. Related to the data, I saw some of you were saying that you were bringing the data from where it was into your sort of local region to work with it. It generally makes sense to work with the data in the region that it is sitting, right? So if we take Sentinel-2, for example, or some of the Sentinel-1 data, depending on which Sentinel-1 data you're working with, that data lives in Frankfurt, right? So this is Germany. And so it might feel weird for you to be sitting in Asia and to do processing in the German region, in Frankfurt region. But there's no difference to doing this versus, well, at least you can do this, right? Technically, you can do this. The reason why you would want to do this is because then you're not sort of incurring the time and the duplicate cost of storing that data locally for yourself, right? If you run your processing in the Frankfurt region right next to Sentinel-2 data that's sitting in the Frankfurt region, then you can sort of use it as fast as possible. It's a very low latency access, but also you don't need to copy any of the data anywhere, right? You can make use of all the data that's sitting there in the region. So you don't need to sort of pay the cost of copying that data twice. Generally speaking, there's no reason to duplicate data storage. And last point was, there was a question around some of the cloud, sort of knowing how to use some of the cloud services. So Anna had pasted a link here in the chat. So we obviously have a lot of training resources. A lot of them are free. There are also paid training resources from AWS and from other people, but there is a lot of AWS training for free. So if you're thinking about how to use a particular service, or just looking for ways to learn more about the cloud, we would have shared this at the beginning of this initiative as well via email. but make sure to check out the AWS training site as well, because they're always adding more things. So I'll stop there. Anna, I don't know if you had anything or if there are any other questions from the group related to any of those points.
Anna, are you there? Looks like you're unmuting, but we don't hear anything. Maybe while you're taking a look at that, Joe, I just wanted to ask, so if, okay, she says she's having trouble with her mic. I just wanted to ask if someone were interested in using, you know, the spot market to do their computations, could they find out how to do that by going to the training website? Is that fairly self-evident, or do they, you know, how complicated is that?
Yeah, so hopefully there's training about it, right? If not, you would just want to search for Spot AWS and you'll find a number of resources. Spot is not a new feature, so there will be a lot of resources on how to use it out there. Yeah. Okay. All right. Any luck, Anna, or let's see. Okay, so Anna is just saying here in the chat that she wanted to remind people about the forum so that we can learn about the issues that you have and then leverage that forum space to where, you know, Joe and Anna can or others can share lessons learned or give advice. If you've, you know, maybe you've lost the email, it was a while ago, maybe about a year ago, I think that we set that up. The link to that Anna has put in, or Joe has put into the chat window. So maybe that's a good place to go to try and make use of a common space where we can learn from each other and share some of the issues. Are there any other issues from a kind of a technical aspect that anyone would like to reiterate or bring, you know, maybe you don't feel like you've quite got the answer you're looking for? Is there anything more along the obstacle, hindrance type theme that anyone would like to share? If not, then we have about just about 10 minutes before we need to close. I see that Ian Jarvis is on the line, and I would like to maybe, since he is, some of you may not know that Ian is the coordinator for GEO-GLAM, the GEO Global Agricultural Monitoring flagship of GEO. So I'd like to kind of maybe get his thoughts on these projects in particular that are oriented towards agriculture and how, you know, maybe these can fit into what GEO-GLAM is doing. Ian?
Yeah, I am lurking out here. I was enjoying the questions. I didn't really have anything to add, so I didn't speak up, but they were good questions. I was really pleased with the discussion around utilization of Sen2Agri and the testing of it. I'm a little disappointed that we weren't able to help Kenya prior. We didn't know you were having issues with using it or that you were even going to apply Sen2Agri. So we could have done something with you sooner, but it looks like we'll be able to address that going forward with GEO Secretariat's help. That's great. The work generally looks at very high quality. I think some of you who are not already connected to GEO-GLAM might want to get in touch with me. We're an open community. We welcome all interested parties that want to contribute and collaborate with other people around the world doing basically the same thing. There's a lot of value in that, of course. And we're pretty low on the bureaucracy, but quite open. In fact, we have an in situ data meeting tomorrow to talk about how better management of in situ data. And that certainly plays into a lot of this work. There's also, I see some opportunities from some of the presentations that we could make connections, and I just want to make connections are where they should be. Things like the Mekong rice monitoring, I'm not clear whether it's already linked to the GEO-rice and Asia rice activities with VNSC and so on. But there's a lot of people doing similar kinds of work. So the more we can make those connections, the better that is for everybody, I think. We all progress faster. So with that, I'll just leave it at that. And thanks, Doug, for calling on me. I probably would have just hidden in the background here.
Yeah. No, I just like people to know who you are. And I see, you know, from my limited perspective, I think I see some potential to support GeoGlam with these projects, especially, you know, the rice monitoring and Asia rice. So I hope some connections can be made there.
Really, that's true. And there's a lot of progress we can make that we haven't made yet using cloud computing in some places of the world. So the better you guys do on these projects, the better options we're going to have to display and demonstrate to others what can be done at relatively lower cost, and also the building on the experience of others, the Agri tools in Amazon and other tools that might come along. I think that's really important and very valuable.
Yeah, great. Thanks a lot, Ian. All right. So as we kind of wrap up here, if anyone's got another question they would like to raise, please feel free to put it into the chat. What I thought might be nice to do to close out our session is just to have each of you in turn give us, you know, what is the one big benefit that you've had from this programming? What has been the added value for you? What have you appreciated? What has helped you maybe do something? You know, we talked about hindrances. Let's talk about the other side. What has this helped you do that you could not have done otherwise? So I see Kizito has a question. So I'll get to that at the very end. But maybe if I could go back to the Indian Data Cube, sorry, not Indian Data Cube, the Agri-SAR crop inventory. Could you tell us, just give us, you know, how you feel you've benefited from this program so far? Maybe they're not online. Avik Bhattacharya, are you still on? Okay, maybe not. Well, then let's go on to, let's see, Kizito, you were next. Do you have anything you'd like to tell us? And then you can go on with your question as well on in situ data.
Yes, thanks a lot, Douglas. I think one of the key learnings or great opportunities we have seen with this project is basically the opportunity to basically prototype ideas quite fast, especially when it comes to how do we just analyze quite fast crop phenology for farmers at a small scale without looking at, okay, how do we get access to the satellite data? So the fact that Agri data, the Sentinel-2 data is already available on Amazon has really helped us to avoid this challenge. So that is one thing that I think has really helped us to get a lot of mileage while we go ahead. So I'm really grateful for that. And we also already had some technical difficulties. Basically, we're a bit late with using the code for our Amazon credits. So I'm glad that, Joe, you were able to help us quite fast with that, and we were able to continue the activity. So I really appreciate the support from Amazon for that. A question that I just wanted to put here, maybe because we are always looking at best practices with field data collection. This is something that I'm sure probably also within GeoGlam has been discussed. I'm just wondering if there are any documentations or links to that can support field data collection activities, which people can be able to share, especially when you're looking at how to use field data in combination for Earth observation, right? So not just getting a GPS location, but if there are any best practices for that, we would appreciate getting to know about that from the colleagues present here. Thank you.
I try that one out, Doug?
Yeah, sure.
Okay, so the couple things. The JCAM, JECAM.org website, we have some field collection guidelines and also guidelines on establishing research sites in the context of the JCAM network. And if you're not familiar with it, it's almost 50 sites now globally doing joint research. So there's stuff there. But as I said, tomorrow we have a meeting on in situ data. And if you're interested, send me an email after this. And my email is ijarvis@geosec.org. And I'll send you an invitation for that. You might just want to hear what's happening. We're just starting. This is our very first meeting. We're kicking off a enhanced in situ data management working group activity. It's enormously popular. I have well over 20, probably well over 25 participants already. People wanting to share or do something around this. You might fit in quite well. And of course, everybody's had the same problems in the last year or so with in situ data collection, but we're all working on solutions going forward to do a better job within our community of managing in situ, and the standards on collection are part of that. So there's a lot of tools within the community as well for collecting and so on and so forth. So anyways, if you're interested, send me that. It's at noon UTC, I believe. So I'll send you the agenda anyways, and the link if you want to join us. That'd be great.
Great. Thanks a lot, Ian.
Pleasure.
Great, thank you. Nosiseko, any comments on how you feel you've benefited so far from the program?
Yes, basically the Center Agri, that's where we benefited the most, especially it being now on a cloud environment. With the product development that we are doing, it has helped us a lot, even though we had some issues there with it, but it's helping us a lot in terms of the products that we are looking at, also like in the temporal resolution that we are looking at as well. So we are quite happy with that, and also just to be working in a cloud environment as well, the exposure to a cloud environment. And also I'd like to thank Joe as well for being there whenever we shouted, especially when it comes to credits and stuff. I appreciate that. But yeah, we're learning and it's great. Thank you.
Great. Thanks, Nosiseko. Michael.
Great. So I too would like to thank Joe for helping us out with the credits that we've had problems with in the past. It seems like you know, we're maybe not the only ones, but thank you so much, Joe. You really helped us out there. The thing that I've really enjoyed about working in the cloud is that we're seeing the places where we can save a lot on cost, not just for this project, but for a lot of the different things that we do. And a lot of the reason for that is that the satellite data is so heavy. You know, the Sentinel data, the Landsat data, it's petabytes of data, and it's if you're processing over large areas, that means we would have to spend probably more than tens, maybe hundreds of thousands of dollars on disks, and just being able to go and access that from S3 over a high-speed network is, you know, it even just on hardware saves us a lot of money. Never mind all the time we don't spend prototyping and building systems and installing virtual machines and all those sorts of things. So I think that there are a lot of ways that we're saving quite a bit of money by using AWS, and I think that maybe something going forward is how do we use those types of cost-saving mechanisms more effectively for the geospatial data? Because when we do use a system, for example, like Agri, even when we do have it running well in the cloud, it's still kind of running on EC2, and that's sometimes less efficient that if you're not using spot instances than something like you know, if you're running small workflows on Lambda where you're getting paid for a small amount of compute. So I think it's part of a larger shift in how we compute things from geospatial data, where we have to think about how to break our workflows into smaller chunks and use the resources more efficiently. That's more of just a general comment.
Great. Thank you very much. And last but not least, Pham Bakviet, any any comments you'd like to make on how you feel you've benefited from the program?
Thank you. We joined the program mainly we learning the new technology, and so far we learned that cloud computation based on Amazon Web Service is very flexible for computation, and we can get the data, the open data from Amazon imagery and another side, like to get the Sentinel one and models for processing the data. So we are still on the progress of learning. So we try to make the optimization on what we are doing. Yeah, thank you. But particularly on Joe, he had some help us for at the beginning. We have problem with the installation in Amazon Web Service, and now I thank you very much. Yeah, that's all.
Okay. Well, thanks everyone. I appreciate your interest, and these are it's very interesting to see all these projects, the progress that's been made, how you've dealt with certain issues. And so thanks again. Tomorrow, if you're able to join us at the same time, we'll be looking at projects that are along the theme of disaster response and prevention. So join us if you can. Otherwise, again, these are being recorded, so we'll make them available, and we'll also make available each of your presentations along with the actual slides that went in them, so that you can check those out, and your bio slides. I just need to find a common spot where I can put all of this and let you access it. So that might be another day or so before we announce that. But anyway, thanks again, and hope to see you again tomorrow. Bye-bye.
Yeah, thank you. Bye-bye. Have a good
Thank you,
day.
everyone.
Thanks.
Thanks a lot. That was great. Thanks. Bye.
Good.
Thank you. Good to see you. Bye.
Bye.
Bye-bye.
Ciao.